Let's do this question. Calculate the kinetic energy of a body of mass 2 kg moving with a speed of 10 meter per second. So it's just a formula we need to use. And if you put the value, we'll get answer as 100 joules. Let's go next question. Yeah, question number 7. How fast should a man of 60 kg run so that its kinetic energy becomes 750 joules? So they're asking for speed. How fast means the speed they are asking, and we just need to just play with the formula here. So kinetic energy is half mv square, and we have to calculate this because this is not given. Mass is given, kinetic energy is given, and if you do that, you'll get the answer as square root of 25. And so square root gives plus minus 5 meter per second. So why two answers? We will report the positive answer because kinetic energy is always positive, we will report that. But if you want to know like why these two answers are coming, because kinetic energy does not matter in which direction the velocity is. So let's say if you have considered 5 meter per second here in this direction as positive, so let's say 5 meter per second this way. Okay, so this will give the same kinetic energy that is discussed here. But if you consider the direction here minus 5, right, again we are getting the same kinetic energy because we'll square it, and while squaring the negative sign goes off. So that's why we are getting two answers here, positive or negative. But we will report the positive answer, 5 meter per second, for simplicity. Question number 8. How is the kinetic energy of a moving cart affected if its mass is doubled and its velocity is tripled? So we are making some changes, and we are asked like how the kinetic energy will be affected. So let's say initial kinetic energy was this half m1 v1 square. M1 is initial mass, v1 is initial velocity. So this is a set of v2. And now let's do the changes which they are asking. Now, if the mass is doubled, say we have make it m2. Okay, so the m2 mass, the second case final mass, is double the initial mass because m1 is initial mass. So we can say m2 is equal to 2m1, and the speed did not change. But no, velocity is tripled. Sorry, the velocity is tripled. So v2 is 3 v1. I thought the velocity is not. Okay. Yeah. In the first question, we will consider that on the speed has not changed, so it will remain same. Sorry, so it will remain same. So now we will see putting these values half m2 v2 square, and then m2 instead of that we will put 2. We will take this 2 out, and we will keep half inside. Why we are doing this, creating this kind of block, so that we can compare, because this was the initial energy. So the kinetic energy has become double of the initial kinetic energy, because see, we have half m1 v1 square is k1. So that's why we just rearrange here so that we get the expression in terms of the initial kinetic energy. So kinetic energy is double of the initial kinetic energy. Let's do this B part where velocity is tripled. So in case of velocity is tripled, the mass remain constant. Okay, so there is no mass change in mass, and the velocity becomes 3v1. So here it will be 3v1. So 3v1 square, and you solve it. Again, I'm taking n9 out and keeping, clubbing these together so that I get the expression of initial kinetic energy, because I'll be able to compare. So this part is already the initial kinetic energy, this one k1, and I can substitute that and I will get the final kinetic energy, or k2 is 9 times k1. Let's do question number 9. A truck weighing 5 into 10 to the power 3 kilogram force. Okay, so weight is given, so we can calculate how much kg it will be. It will be the same, 5 into 10 to the power 3 kg, right? So it is here is the force due to gravity is given, but that is can be simplified very easily. We just have to take care of this as mass. And a car weighing this much, so the mass is 500 kg, are moving with the same speed. Compare the kinetic energy, so we can finish it off here. Kinetic energy of truck kt, we can write kc like this. We have to compare, we will take the ratio, half and half will cancel out, that's why not shown here. And then the speed is also same, so they will also cancel out. Only the mass ratio we have to take. So what is the mass ratio? Just do 5 into 10 to the power 3, and divided by 500 divided by 500 sorry 5000 divided by 500, so that will be the answer 10 raised to 1. So 5,000 divided by 500, that will be our answer 10 raised to 1. So the kinetic energy is in this ratio. For the same kinetic energy of a body, what should be the change in its velocity if its mass is increased 4 times? Same kinetic energy, we are keeping the kinetic energy constant. What should be its change in velocity if its mass is increased 4 times? Again, the expression half mv square. So if we are keeping this constant, so whatever changes we are doing here, that should be nullified by this. Then only this will be constant, right? Kinetic energy has to be constant. So if we are uh, mass is increased 4 times, if we are multiplying this, what should we change in the velocity? I should make it 1 by 1 4 somehow. Or how we can I make that? That I can make the velocity drop by, instead of 2, I can write just half the velocity, so that we have to take the square of it, then it will be 1 by 4, and then it will be cancel out, and we will get the same kinetic energy. So intuition wise, you can also solve these kind of questions mathematically. Let's see how we can solve. So we want same final and kinetic energy. Initial kinetic energy K1 is equal to K2. Let's say initial was this and final was this. Mass is increased 4 times. M2 is equal to 4m. The final mass here. We'll put that. Masses will get cancelled. M1 and M1 will get cancelled. And we will get expression V2 square is equal to V1 square by 4. And we will take square root. We will get V1 uh, divided by plus minus 2. We will take the positive value V1 by 2. So the velocity has to be halved. So this is what by intuition we were also getting.